Value for the AI SL syllabus. Expected value is really simple. The formula for it, which is indicated here, looks really confusing, but in reality it's just two simple calculations that you need to do. So in this video I'll explain what expected value is, and then I'll explain how to do it really simply through an exam style question. Expected value simply means when you have discrete random variables, it's the average value that you would end up getting, given the assumption that you carried out an infinite number of trials on that experiment. And it's indicated by the symbol EX. EX, expected value of X, the variable. So for a discrete random variable of X, here it says it's the sum of the probability of each of the values of X occurring. Now this looks confusing, but I'll explain that just now with an exam question. Let X be the number of magazines bought by a customer. The probability distribution for X is presented below. So a customer might buy 1 magazine, 2 magazines, 3 magazines, 4 magazines, or 5 magazines. And these are the probabilities of them buying each of these values. So this means the probability of a person buying 1 magazine is 23%, 2 magazines is 38%, and so on. So given that, you would assume most people are going to buy 2 magazines, as it has the highest probability. But remember, the expected number is the average number that you would get had you done an infinite number of trials. It's not just a whole round number of 2, so there's some calculations associated with it. What you need to do is this: 1 times 0.23, add that with 2 times 0.38, add that with 3 times 0.21, add that with 4 times 0.13, add that with 5 times 0.05. Do you get what I've just done? These are the odds of, these are the numbers of magazines people have the ability to buy, right? You can either buy 1 or a maximum of 5. These are the odds of each of those. So if you look at here, 1 times 0.23, that's the probability of somebody buying 1 magazine. Likewise, 2 times 0.38 is the probability of somebody buying 2 magazines. 3 times 0.21 is the probability of someone buying 3 magazines. By that I mean 0.21 is the probability. When you multiply that by 3, that's the number of magazines that people will buy on average. And when you take the sum of it, you will get 2.39. And that's going to be the expected value. 2.39 magazines. Because you've taken the probability for each variable and you've multiplied it and you've added it together. That's the average number of magazines that people will buy. Does that make sense? Yes, it does, because 2 has the highest probability of occurring, right? Hence the 2 over here. And there's a lot more probability of things happening that's bigger than 2 than smaller than 2. 23% is the chance of people buying 1 magazine, but 21 plus 13 plus 0.05% are the chances of people buying more than 2. So it makes sense that the value is skewed towards greater than 2, so 2.39. That's expected value.